One of the things that humans can do is they can control the rate of a chemical reaction. So chemical reactions take place naturally, constantly in the living world, and in the non-living world, of course, when volcanoes are erupting, all that kind of thing. But humans are able to control how fast they happen, and that helps us to manipulate things, to manufacture chemicals, to build things in the world around us. There are a number of ways that we can manipulate that rate, but first we've got to think about how chemicals are actually behaving. So remember that atoms move. In a solid, they just vibrate on the spot. In a liquid, they move around and they touch each other. And in gases, they're moving really rapidly and are spaced out. And as we're increasing the temperature, we're increasing the kinetic energy of that substance. Okay? Now that idea is important because in order for a reaction to occur, the reactants actually have to bang into each other. And not only do they have to bang into each other, they have to bang into each other the correct way round and with enough energy to react. Okay? If they're moving too slowly, then they just bounce off and no reaction occurs. If they're facing the wrong way, again they just bounce off and no reaction occurs. But if they've got enough energy and they're the right way round, then we get a chemical reaction. There are 5 basic ways that we can increase the rate. We can increase the temperature, we can increase the concentration of our reactants if they're in solution, dissolved in water. We can increase the pressure of gases, because when we're increasing pressure, what we're actually doing is adding more particles in the same area. We can increase the surface area of solids, or we can add a catalyst. Okay? When we're doing that, what we're doing is we're changing how often they collide, which is called the frequency of collisions, or we're affecting what proportion of them have got enough energy to react. Because remember, if they don't have enough energy, they just bounce off without reacting. So if we look at surface area, first of all, look at that top diagram. That's got a relatively small surface area. So only those atoms on the outside are available to bang into the other reactants. So only the ones on the outside can react. If you take the same number of atoms in our green, but then we split them up, then many more of them are now available to be banged into. So what that means is we increase how often our reactants collide. You're still going to have the same percentage of them that bounce off without reacting. That's okay, but if we just increase the raw number of collisions, then you're going to get more collisions that actually work. Concentration or pressure work in the same way. If we increase both of these, what we're doing is we're increasing the number of particles that we've got in that area. Okay? That again increases how often they can collide. We've got a higher pressure or a higher concentration, that would give you the same picture. What we've done is we've added more dots. More dots mean they're going to bang into each other more often. Okay? If they bang into each other more often, then we're going to get a faster reaction rate. Now temperature is a little bit different. Temperature increases the kinetic energy, so it means they move faster. If they move faster, they bang into each other more often. So again, banging into each other more often, we're going to get more reaction, faster rate of reaction. But what we're also doing when we increase that kinetic energy is we increase the percentage of them that have got enough energy to react. Because if you remember, they had to have enough energy to react, otherwise they just bounced off without reacting. So temperature has a big effect because it changes both. It increases how many of them are going to bang into each other and what percentage of those collisions are actually going to work, which we refer to as the proportion of successful collisions. A collision that actually results in a reaction rather than a collision that results in them just banging off and nothing happening. And then catalysts. Now catalysts, again, increase the proportion that have got enough energy to react. But they do it in a different way to temperature. They don't increase how much energy they've got. What they do is they reduce how much energy is needed for the reaction to occur. It's what we call the activation energy. It's seen down here. So without the catalyst, we need a lot of energy for them to react. With the catalyst, we need a much smaller amount. And if we need a smaller amount, more of them are going to have that amount. So more of them will react.